Hello everyone, welcome to our PBL Level 1 Physics project. And now let's introduce our materials. First of all, we're going to need our motion sensors. I'm going to use a motion sensor, but if you want, you can use a video camera, and then you can record. The video, and you can do a video analysis. So I'm also going to need the USB link to be able to connect my motion sensor to the computer. And then I'm going to need an angle indicator to be able to indicate the angle of the track. And we're going to need a rod clamp, and we're going to need a rod. So we're going to connect that clamp to the rod, and then we're going to be able to change the level of the clamp, the track. And of course, we're going to need a cart that is going to have a spring at the end. And we're going to need a stopper. So we're going to use that at one end of the track. And we're going to need a base to be able to mount that rod to the base. And finally, we're going to need our track. And let's move to the setup, and let's see how we're going to do the setup. First, we're going to connect our USB link to the computer. And then make sure that the green light is on. And after it's on, you're going to bring your motion sensor, and then you're going to connect your motion sensor to the USB link. Next, we're going to screw our rod to the base. Then we're going to use our rod clamp, and then we're going to put it through. And I'm not going to screw that yet because I need to connect that to the track. Next, we're going to merge that guy to our track. And to be able to do this, we're going to have holes at the end, so space for that. So make sure that goes through the side. Once it passes through, you just slide it up. And whenever it's ready, whenever you put it through, you just screw that. Next, we're going to mount our stopper to the lower end, and make sure that you have your magnet side is facing to the motion sensor that we're going to put. And that's going to go through the side. Let's screw that in. All right, now this right side is ready. Now we're going to go to the other side, and we're going to put our motion sensor. But before we put our motion sensor, we're going to put our angle indicator. Next, we're going to have our angle indicator, and it also has the screw on the side, and that is going to go through the hole from the side. And once it's in, you should slide it all the way down. Next, we're going to mount our motion sensor to the end of the track. And for this is our Pasco motion sensor, and this is from Pasco again. So they are going together pretty good. So you have a space over here, you have a gap, and that gap is basically for the track. And make sure that you put your motion sensor through that gap to the track. Now it's ready. This is our experiment setup. And what we want from kids is we're going to do the setup, or if you want, you can get students to do the setup. It's up to you. But that's a long setup. So if you do not have enough time, you can just do it ahead of time, and then you can just let students do the investigation. So in the first part, we're just going to be asking students about the angle of the ramp and the motion of the cart. So first, you let students to observe the motion of this cart. So what we're going to have is we're going to have this guy. So that has 3 stages. So I'm going to press it until I see 3, not all the way in, until I see 3. All right. So and then I'm going to place it over here. and let students observe what's happening, and you can ask them to define the motion of the cart. So it's going to be bouncing a couple of times, and after a while it's going to stop. And the question is, what is going to happen? Or what's going to change in the motion of the cart if you decrease or increase the angle of the ramp? So this is the question that you're going to be asking. And try not to use what's going to happen to height. All right, because we're trying to get them think or get them observe that the height is actually staying the same. Because due to the conservation of energy, since we're going to have the same energy, then you're going to convert that energy to the gravitational potential. So you need to have the same height all the time, no matter what the angle is. But since they are trying to investigate that, we are not asking what happens to the height. We're just asking what is going to change about the motion. All right? And we're going to ask them to describe the motion if we change the angle of the ramp. And then in the next part, we're going to be asking them whatever their theory is. For example, they're going to say it's going to go like longer. All right? Then if that's their theory, they can. We're going to be asking them to prove that. If they say that it is going to go at a higher speed, all right, so we're going to ask them to prove that. But our key thing over here, you should make them like list everything that they can actually investigate it over here. And the final thing is the angle. The height. So we need to let them see that the height is actually staying the same. All right, so here's the key thing is the height. So what we're going to have over here, I'm going to change the angle by 5 degrees, and then I'm going to measure the height that it is reaching on the y-axis. All right, so for this, we're going to need a little bit of math, because this height from this position to this position is not going to be measured from that distance. We need to get that difference from that position to that position. We need that difference. So how are we going to measure that height? Since this is my angle and this is my length, and this motion sensor is measuring that distance, if you multiply this hypotenuse with the sine of the angle, that is going to give you the height. So that's what we're going to do. So we need the angle, and then we're going to need this value. What's your displacement? And then we're going to multiply this height, that linear displacement, with the angle's sine value. Then we're going to find the heights, and then we're going to compare those heights with different angles. I'm going to try with 5, 10, and 15, and then we're going to move to the next part. All right, now our angle is 5 degrees, and what we're going to do is we're going to launch it, and then we're going to see how high it is going to displace on the y-axis. And to be able to do this, first we need to measure that distance and multiply that distance with the sine of the angle. And to be able to measure the distance, I'm going to need my motion sensor, and for this I'm going to need the software, and I'm going to be using Pasco Capstone. And I'm going to need a graph, so I go to the graph and double click on it, and this is my graph. And since I have motion sensor, I'm going to need to measure the distance, and this is going to measure the distance. All right, and what I'm going to do now is I'm going to let it record, and I'm going to let it move. All right, let's start. Right now, it is, as you can see, it's measuring 1 meter. And this is because of the distance from motion sensor to the cart. Since right now it is at 1 meter, that's what it's measuring. All right, I'm going to stop this, and I'm going to start over again. All right, let's start, and let's see. All right, that data is enough for me. So since motion sensor is measuring the distance from sensor to the cart to the object, at the beginning that's where it was, and then it measured that distance. So that is basically how far it came. So I need the distance from my initial position, which is 1 meter, to whatever that position is. And for this, I'm going to use one tool, the Pascal stone, capstone, and this is your coordinate tool. So if you click on it, add a coordinate system. With this one, you can choose a point on the graph, and it's going to tell you the coordinates of that. And if you right click on it, then it's going to show you the delta tool. And with a delta tool, then you can have 2 points, and that's going to tell you the differences. And 1 point is going to go to the beginning, that's my initial position, and the second one is going to go to that point. And let's make sure that it is good enough. All right, that's pretty good. So right now, as you can see, this is telling you the delta time. So how long did it take for you to go from that initial position to the final position? And that is telling you your displacement. And my displacement is 0.75 meters. So what I need to measure my displacement from my initial position to the final position on the y-axis. So what do I need? That distance multiplied by the sine of the angle. And for this, I'm going to go over here. So I'm going to measure it for 5, 10, and 15. This is degrees, and if you're using, I'm going to use Excel's function, so that's why I have this degrees in radian. And because sine value is not measuring in degrees, I need to convert it to radian first. And for this, you press enter, and of course, this is only for me right now. You just need sine of the 5. But since I'm going to do it through the computer, I'm just going to convert it to radians. So you write radians, double click on it, and then select which angle, close the parentheses, and then that's going to give you the radian. And now, this is your radian of 5 degrees, and then I'm going to need a sine of this guy. So then enter, and another function, which is sine, and open a parenthesis, enter your angle, close the parenthesis, and here is your sine value of that. And my delta x, what is my delta x? Let's go. My delta x is 0.75. So that is 0.75. All right, so I am going to need my height. And my height is going to be what? My displacement times my sine of the angle. So equals displacement times my sine value. So that is my height. All right, 0.06537. So that's my displacement on the y-axis. So now I'm going to change this angle to 10 degrees, and let's see what's going to happen. All right, now we're going to move to the next part, and over here we change our degrees to 10 degrees. And basically you are playing around here, and that's how you change your angle. All right, now we're just going to record data. Record it, and again, it's 1 meter. All right, so that is basically how high it went. Let's make our data a little bit larger. So I'm going to need my initial and final positions. And again, I'm going to use my delta tool over here. First coordinate, then right click on it, show delta tool. So that point goes right here. That point goes right here. So my delta x is 0.41. So let's go to our Excel. My distance is 0.41. And my degree is 10 right now. So I wrote the functions over here. So you select both, and then you bring it down, and that is going to tell you your sine value. And now I need to bring it down too, and let's see what we have. All right, so my displacement on the y-axis, it was 0.065. So it was like 6.5 centimeters, and now it's 7.1 centimeters. So there's like a 6 millimeter difference. And for this, you can ask for like error. At this point, you can ask for a cause for an error. So what is the reason that this is like changing? And the most common problem that you might have is the angle, because the angle indicator is really difficult to set it to exact number. Or the other thing is the friction, of course. So in the first one, you're traveling that much of distance, and then over here, you're traveling that much of distance. So over here, you are having longer, so that means you're going to have more friction. So you would expect your height to be less in this case, and that's what it is, actually. All right, so you are losing more energy over distance. And for example, even a tiny difference in the angle, 1 degree difference, can change your results a lot. As you can see, they're pretty close right now. So the only difference is like 1 millimeter. And again, that's because of the degrees. So make sure that you are putting your degrees accurately. Now I'm going to try 15 degrees. Now it's 15 degrees, and let's see how it is going to change our height. And let's, okay, so we're going to use our delta tool again. Right click on it, show delta, and that is going to come over here, and this is going to go. All right, as you can see, this is 0.28. So let's see our data, and this is going to be 0.28, and let's see our height. As you can see now, it's 0.72. So as you increase your degrees more and more, the distance that you're traveling is getting less and less, and the height that you're getting is a little bit less, more and more. And this is because of the friction. So it's very important that you are actually discussing that part, because then kids might think that if you increase the distance, then the object is going higher and higher, which doesn't actually make sense. So the only explanation for that is you're having more and more distance traveled, and then due to the friction, you're losing more and more energy, so you're going to have less and less height. All right, so basically that is going to be the investigation part of the first part, which is when you change the angle, yes, it is going to go less distance on the x-axis, but your displacement on the y is going to be the same if you didn't have the friction. Or, including the friction, it's going to be less and less, because you're going to be traveling less and less distance, so you're going to be losing less and less energy, so you're going to conserve most of your energy. All right, now in the next part, we're going to see the effect of the compression. So we're going to release it from level 1, from level 2, and level 3. And then we're going to see how is this going to change the motion of my cart. And in this case, I'm going to use the same angle, and I'm going to go back to lower angles, because at this height with low compression, I'm not going to be able to have an accurate data. And let's bring it down. All right, in this part, we're going to be using different distances of compression. So this guy is going to have 3 different levels. So as you can see, 1, 2, and 3. And I'm going to press it all the way in, and that's going to be my 4th distance. All right, so we're going to have 4 different data for 4 different compression. So first I'm going to start with the first level, and each level has 2 centimeter difference, and except the last one, and the last one is going to have 7 millimeters difference. All right, so I'm going to try with 2 centimeters, 4 centimeters, 6 centimeters, and 6.7 centimeters. So first I'm going to start with the first level, which is 2 centimeters. And then I'm just going to launch it with 2 centimeters compression. And let's measure our data. So let's measure the distance from first point to the second point, last point. That's your final, that's your initial, and that is 0.06. So it's just 6 centimeters. So let's go to our Excel. So right now, I already put compression levels 0.02, 0.04, 0.06, and 0.067. And my mass is still the same. I'm not changing my mass. And I am having the same angle, so this is going to be still the same. So my distance for this one is going to be 0.06. And my energy is going to be my mass times my gravity, which is 9.81, times my vertical height, which is distance times sine of the angle. So whenever I put all of them together, that's what I have. All right, now I'm going to move to the next one, and that is basically 4 centimeters. So I'm just going to press it twice, and now as you can see, that is in the second level. And I am going to start to record the data. So let's measure our displacement. We're having our delta tool again. Initial position, final position, and my displacement is 0.27. So that is going to be 0.27. And let's see our our energy. So our energy changed from 0.18 to 0.81. So I doubled my compression, and my energy has increased by like 4 times, 4.2 times. And let's try the third level. And let's see what we have recorded. So let's measure the distance, tool, coordinate tool, and then delta tool. All right, so my displacement is 0.61 this time, 0.61, and let's measure that distance. And it is 0.18. And now let's move to all the way down. So not to the third level. At this position, press to that button and then push it all the way in and then let it go. And then it's going to be compressed all the way in. Now it is touching to the stopper, and then what we're going to do right now is we're going to record it from the 4th level. And let's see what we have now. So my displacement is 67, 0.67, and my energy is 0.2. All right, now what we're going to do is we're going to compare those two values. We're going to compare how distance that you compress and how energy related. All right, and if you want to extend this a little bit more, then you can compare your potential energies to your kinetic energies. And for this, you're just going to need your kinetic energies. And because you have your mass values, and then you're just going to need your velocities. And over here, all you need to do is, over here you can select the run. So this is for first compression, second, third, and fourth. So what you're going to do is you're going to open a new page, and then double click on the graph, and you're going to need your velocity. And this velocity is for fourth run. So which one do I need? I'm going to need for the first one. So I'm increasing my velocity all the way up. So that's my maximum velocity. And basically that is my initial velocity. So that is when I change my compression. All right. But this data is going to be a little bit wrong, because this velocity, when you compress, when you change your compression by like 2 centimeters, so there will be a height difference, but you might ignore that difference. So let's see what is our kinetic or velocity at this point. Your velocity at this point is 0.32. So you can add a new speed column over here. So whenever you compress it that much, then your speed is going to be 0.32, I guess. Yes. All right, now let's move to the next one. Run 2, and let's see our speed at this point. That is 0.74. And let's go to the third run. And let's measure our speed now. And that is 1.15. And let's see the last data. And over here, where's my delta tool? Right here. And 118. All right, so these are my speed data right now, and what I need is I need to find my kinetic energy. So this is my potential energy at the end. So that is my potential energy change from that position to that position. So I need to find my kinetic energy. So my kinetic energy is going to be what? 1/2 mv squared. So that is going to be equal to 1/2, which is 0.5, times mv squared. So my mass is 0.25 times my velocity squared. So speed times speed again. So that is my kinetic energy. And let's compare our kinetic energies. All right, now we have our kinetic energy and potential energy values. So now you can investigate, or you can talk about, you can discuss the reasons for the error and the reasons for that decrease, or you can investigate the potential energy and the compression levels. So, and over here what we did, we doubled our compression. So we doubled the x, and then we would expect our potential energy. Theoretically, we would expect our potential energy to be quadrupled. And over here we tripled, so that should increase by like 9 times. So they're not like 9 times, it's like increasing by 10 times, but they're pretty close theoretically. All right, and with the spring, it is not going to be like 100% efficient in my system. So this is another reason that we are not having perfect answers or perfect results. So that is going to be basically the analysis part. So why is these values are more than the kinetic energy values? So what can be the reasons for those? And you can compare those two values and then what is happening over here, why this is not quadrupling or why is it more than that. So you can see, you can discuss all those differences. All right, and so basically that is it for the experiment part. And now we're going to talk about our science practices that we covered in this experiment. What are the science practices that we have covered in this experiment? The first one is students can pose scientific questions. In the first part, after their observations, they need to make an hypothesis, and then they should have tested that. So that was the part. And next one is students can justify the selection of the kind of data needed to answer a particular scientific question. Our question was how the compression is changing the potential energy. So we were just having a compression and we needed to be able to calculate the potential energy. So basically they needed to decide which variables, which measurements they needed to do to be able to compare those two. Next, students can collect data to answer a particular scientific question. Again, in the second part, after they decide what to do, they have collected their data and then they have compared their potential energies and the compressions. Students can analyze data to identify patterns or relationships. After they have collected their data of potential energy and the compressions, they compared those two values, and then they also calculated their kinetic energies, and then they also compared that kinetic energy and potential energy. And the last one, students can evaluate sources of data to answer a particular scientific question. So over here, we had differences in between kinetic energy and potential energy. And in the first part, again, we had differences in between the heights when you have like more and more distance. So over here, we were able to we were discussing what is the reason for those differences. So the source of those errors was mainly friction, and basically that is the practice that we have over here. So now, these are basically the science practices that we have covered in this experiment, and that is it for today, and thank you for watching. See you next time.